Okay, so today our class period, kind of as I just shared with you all, but I'm kind of telling the people at home, it's going to be broken into two parts. So I'm going to be doing a little bit of it now, then we're going to break for lunch, and then we'll come back and kind of continue this up. So this video is going to kind of have two parts. But we're moving into the 10th lesson of chapter 4. Okay, some of you I'm already seeing your willingness to kind of participate. Others of you I'm not seeing that. Come on. Remember, this is a new skill. You should be writing this down. You see something come up on the screen. That's like the ultimate clue. My teacher is expecting me to write this stuff down. Not just stare at me. You're not going to learn by doing that. Okay? We're getting into this order of operation stuff. And yes, you guys have heard this before. So some of you are sitting there going, why is Miss Malone saying this is going to be so hard? I know what this stuff is. Well, sure, you've heard of order of operations. You've done it in a really small, what I kind of call baby way, but you haven't seen it in how 5th grade is going to bring it. That's different, okay? And that's what we're going to kind of explore today. I don't want you to spend class time today writing notes. You have to spend class today listening first. Listen first, then take notes. Because if all you do is just write, you're going to miss everything I'm saying. It's like if the volleyball coach is teaching you how to run a play, and the whole time they're teaching you how to run a play, you're writing on a piece of paper. Are you going to be learning what the play is? No. So it's kind of like me teaching you this. If the whole time I'm teaching you how to do it, you're just writing, you're not going to learn. So we're going to listen first and then write what we need after that. Okay? So today, order of operations, this is probably not new. We're going to be exposed to PEMDAS. So now, if you need this, great. If you don't write it. Don't write stuff you don't need. Okay? PEMDAS, as you have heard in the past, because I've used this term many times, listen first, people, not write. If you're writing, you're not going to hear me. Every letter of PEMDAS represents a math operation. Some of those you're very familiar with, like these M's and the D's and the A's and the S's. You're very familiar with multiplication, division, addition, and subtraction. You're somewhat familiar with the P, which represents parentheses. The exponent one, though, that's one that you're not super familiar with. This is a part of 5th grade PEMDAS. So, now, you have seen this before, people, okay? Where have you seen this little exponent thing in the past? Do you remember, James?
It was, I think, the first chapter we did exponents, which was multiplying two 3 times would be 6.
Beautiful. It was where we looked at, and we actually explored it with these big tins. Do you remember this?
Yeah.
It was like a tin with a little tube kind of hanging next to it. Now, I'll give a piece of candy to somebody who can tell me. I haven't even asked it yet. You're all raising your hand. Okay? I'll give you a piece of candy if you can tell me. That big number that sits next to the exponent is called something. What is it called? Braden? Sorry, Braden.
Base number?
It's the base number. Excellent, Braden. Whoever you are. Braden. Holy smokes. Gonna give something candy. Okay. This thing is called the base. So the big number, so like in my example here, that's the base. But down here, kind of in my purple description, the 2 is the base. The base always changes. And as James told us a second ago, the thing that we learned way back when we kind of learned to do this is that the base tells us how many times we multiply that number, okay? So if the base is a 2, how many 2s, if the 3 is an exponent, how many 2s, James, am I going to multiply?
You would need 3.
I'm going to multiply 3 of them. That's, oh my gosh, Miss Malone. That's what that, Miss Malone is all jacked up. Hold on. Okay, let's try this all again. That's how many 2s you would need. So 2 to what we call the 3rd power is really 2 times 2 times 2. Now, what is 2 times 2 times 2? It's not 6. Remember, we got to work it in pairs. So this right here is going to give me an answer. And then that answer times that extra 2 is going to tell me what my total answer is? Carson, what is it? 8. Good one. So if the problem is like 2 to the third power, then the answer to that is 8. Now, if you think back to when we played with it with like bases were a 10, and we kind of had like to the third power. Do you remember the shortcut we learned with that? What did we learn, Max?
Just do whatever the exponent is times 10.
Well, you could. So we could say this is really like 10 times 10 times 10. But what was the shortcut? Yeah, go ahead, Max.
We added it.
We added what? Added what?
Added zeros?
We did. This exponent told us how many zeros we needed. Remember, we learned that we just dropped our 1 and we put 3 zeros behind it. Kind of remember that shortcut?
Yep.
Well, that shortcut only works if you have a base that's a 10. But in today's lesson, our base isn't going to be a 10. It's going to be those other numbers. So we have to kind of follow what James told us here, how to know what an exponent is. The biggest mistake that fifth graders typically make is they want to do the big base times the small little exponent. They want to say that 2 times 3 is 6. That's the place where the biggest mistake happens. And you just got to be careful with that you don't do that, okay? Because that's not what exponents are all about. Exponents tell us how many times we multiply the base, okay? So let's just practice one more just to make sure we have complete understanding of this. If our base is a 4 and our exponent is a 2, then what is this problem really going to be?
Like 4 plus 4.
Not plus, not plus.
Times.
Times. It's going to be 4 times 4, which is equal to?
16.
16. Okay. So if it's 4 to the second power, that's really equal to 16. Are you going to need that for order of operations?
Yes.
Yes. Because this is math right here, people. This is math. And if the problem gives you an exponent, you got to know how to turn that exponent into a number. Okay, just like if they give you 5 times 8, you got to know how to turn that into a number. So if it's 4 to the second power, you got to know how to turn that into 16. All right, so anybody not clear on what those steps, what the P and the E and the M and the D and the A and the S represent? Pretty clear on that?
I know it's pretty meandering, but when in real life would you use exponent?
Well, anytime you do anything with algebra, so you might have somebody like instead of saying 4 times 4, they'll say 4 to the second power. That's an exponent. Or instead of saying 5 times 5 times 5, 5 to the third power. Okay? It's just another way to write a multiplication problem. And you'll see it all the time in algebra. So when I was home yesterday with my kids, because I'm normally not home when they're doing their high school math, I got to hear the teacher tell Lucy, and she's 18, and I heard the teacher say, and she's in a calculus class, which is a really high math class, and I heard the teacher say, okay, now everybody, you got to the point where now you just use PEMDAS to solve the rest. So see, even at 18 years old, she's still using PEMDAS to solve math problems. So this is something that's never going away, okay? So there are 2 important notes that you will need to add to your notes, though, and those notes are right here, okay? It's the red and the blue stuff. And right now, it's not going to make any sense. I'm going to stop talking so that you can write it down, and then we'll talk about what it means once you finish writing. Okay, now some of you, you've copied this down, you have kind of read it to yourself, and some of you are like, oh, I get it, I know what this means. And then other people are kind of a little bit foggy as to what these little notes are here trying to tell you, but I will tell you these are the most important notes that you're gonna need with PEMDAS. If you don't pay attention to what this red and blue stuff says, you won't end up with the right answer when you practice some of these problems, okay? So here's what it means. All right, let's say, for example, that you have a problem. I'm gonna give you kind of a baby PEMDAS problem, okay? So let's say that you have a problem and your problem is 4, actually, wait a second, let me get rid of this. Okay, let's do this. 4 minus 1 plus 3. All right. This is what I call a baby PEMDAS problem, okay? Inside that problem, I see 2 math operations. I see some subtraction, and I also see some addition. So the question is, how do I know what I do first? Well, let's go back to those little notes that Miss Malone just gave you right up top here. And those notes said that once you have only addition and subtraction left, you work left to right. So in that problem down there below, which math operation is on the left side of that problem? Because this problem has 2 sides. This is a side, and this is a side. So which math operation is on the left side, Dominic? The subtraction. So that's the stuff I'm going to have to do first. Even though PEMDAS is really PEMDAS, I mean, it looks like addition's supposed to come before subtraction, but it really doesn't matter. We call it PEMDAS because with the letters in that order, it makes it make a word. If we reverse some of these letters, it wouldn't even make a word, would it? So these guys right here are kind of like a pair. When you get to that pair, you work whatever's on the left. In this example, as Dominic told us, the subtraction's on the left. So this is what I'm gonna actually do first. What's 4 minus 1?
3.
3. Plus my extra 3 gives me 6. Okay. If I wouldn't have worked it in that order, if I would have done the addition first, would I have ended up with 6? No. You will always end up with an answer with math. It's just not always going to be the right one. Okay, so let's try another one. Well, what if instead of it being addition and subtraction, what if it was multiplication and division? So what if it was 4 divided by 1 times 3? Well, this blue stuff up here tells me when working with multiplication and division, you also still work left to right because multiplication, what in the world? Multiplication and division are also kind of a package deal. They work in pairs. And you work these things from the left to the right. So in that example down below, Sophia was wanting to kind of share with us, what do you think you're going to do first?
So what you do first is 45 by 1.
Why?
Because it's going left to right, and that's what the rule says.
Because this is what's on the left. The division sign is on the left of the problem, and so that's what I'm going to do first. What is 4 divided by 1?
4.
4. Times your leftover 3?
12.
There's your answer. Okay. Do those little notes you wrote down make sense?
Yes.
Yes.
But those are baby problems. You kind of saw those in 4th grade. After lunch, we're going to kind of kick this up a notch. And we're going to kind of explore some more challenging ones. Okay, so let's pause our lesson and we'll come back to this after lunch.
I do this for fun sometimes.